Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. AIPs Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a hexagonal pyramid having base edge 30 mm and axis height 70 mm resting on its base onto the horizontal plane, while the two adjacent edges of the base, they happen to be inclined at an angle of 30 degree with respect to the vertical plane. So here the orientation of this hexagonal pyramid with respect to the two reference planes will be such that these two edges, they happen to be inclined at an angle of 30 degree each with respect to the vertical plane. So this is the orientation of the hexagonal pyramid as it is going to rest with its base on the horizontal plane. Now this hexagonal pyramid, so here we have the hexagonal pyramid available over here. Now this hexagonal pyramid has been cut by two section planes which meet at the midpoint of the axis. So we know that the height of the axis happens to be 70 mm. So now we can measure the distance of 35 mm from the apex of this hexagonal pyramid, mark a point onto the axis of this pyramid over here. Now this has been cut at the midpoint of the axis by two cutting planes. Now one section plane which is available onto the left hand side, so this is inclined at an angle of 45 degree to the horizontal plane, and while the second section plane which happens to be available on the right hand side, that is this cutting plane, so this is inclined at an angle of 30 degree with respect to the horizontal plane. So this is an auxiliary inclined plane inclined at an angle of 45 degree to horizontal plane. This is also an auxiliary inclined plane which happens to be inclined at an angle of 30 degree with respect to the horizontal plane, and both of these cutting planes, they meet at the same point, that is the midpoint of the axis over here. So now we are required to draw the sectional top view projections of this truncated hexagonal pyramid. We are also required to draw the true shapes corresponding to these two cut sections which have been cut by these two auxiliary inclined planes inclined at 45 degree and 30 degree with respect to the horizontal plane. And we are also required to project the true shapes onto the single plane as well. That is, usually whenever a cutting plane is cutting the solid in this orientation, so true shape will be obtained over here. Similarly, whenever the cutting plane cuts the solid into this orientation, the true shape of the cut section will be available over here. Now these two true shapes, we have to merge it or combine it onto the single reference plane over here. Now let us proceed with the construction of the top view projections of this hexagonal pyramid, as the observer is going to look at this hexagonal pyramid from the top. So we know the orientation of the base of the hexagonal pyramid onto the horizontal plane. Now we know that the two edges of the base of this hexagonal pyramid, they happen to be inclined at an angle of 30 degree with respect to the vertical plane. Now we have obtained the top view projections of this hexagonal pyramid onto the horizontal plane, and we know that the edge length of the base, it happens to be 30 mm. So now once we have drawn this hexagonal projection onto the horizontal plane, so let us mark all these points corresponding to the base of this hexagonal pyramid. So these points, they happen to be A, B, C, D, E and F. Now let us evaluate the axis point corresponding to this hexagonal pyramid. So in order to evaluate the axis points, now we have to join the three diagonals AD, BE and CF of this hexagonal pyramid. So wherever these three diagonals corresponding to the base of this hexagonal pyramid, they are going to intersect, we obtain the points O and O1 over here. So the O point, it corresponds to the apex point of the hexagonal pyramid, while the O1 point, it represents the base axis point of the hexagonal pyramid over here. Now we can draw the projectors through the points B and A onto the XY reference line. So we will be obtaining the points A dash and B dash onto the XY reference line. Similarly, the points C and F, they will be projected as C dash and F dash onto the XY reference line, and the points D and D, they will be projected as points D dash and E dash onto the XY reference line. So we have been able to obtain all the 6 points of the base and the axis point of the base, that is O1 dash over here. So this way we have been able to locate all these points onto the horizontal plane, because these points, they correspond to the base of the hexagonal pyramid. Now this is the axis of the hexagonal pyramid. Now we know that the axis height of this hexagonal pyramid happens to be 70 millimeter. So once we mark this axis height is equal to 70 millimeter, so we are able to obtain this point corresponding to the apex in the front view projections over here. So the name of this point will be O dash. Now we can join O dash A dash, we can join O dash B dash. Similarly, we can join the slant projectors O dash C dash and O dash F dash, and we can also join the slant projectors O dash D dash and O dash E dash over here. Now one thing we need to understand, that the slant projector OA, it lies on the rear side of the solid, as the observer is going to view this hexagonal pyramid from this orientation. So the front view projections O dash A dash should have been drawn as a dotted line, but these dotted line projections corresponding to the slant edge O dash A dash, they have been superimposed by the slant edge OB, which is appearing on the front side of this hexagonal pyramid, and this slant edge OB, it is going to cover, or it is going to overlap with the slant edge OA, which is lying onto the rear side. So that is why the object line projections corresponding to the slant edge OB in the front view projections O dash B dash, they are going to supersede or overlap the dotted line projections corresponding to the slant edge O dash A dash over here. Similarly, the slant edge OF, it is also lying on the back side, but again it has been covered by the slant edge OC in the front view projections over here. So this way the dotted line projections corresponding to the slant edge O dash F dash, they will be covered or superimposed by the object line projections corresponding to the slant edge O dash C dash in the front view projection. Similarly, over here also the slant edge OE lies on the rear side, the slant edge OD lies on the front side. Now this slant edge OD, it is going to cover the rear slant edge OE over here. So into the front view projections, we are going to obtain, that is the object line projections corresponding to O dash D dash, superimposing the hidden line projections corresponding to the slant edge O dash E dash over here. So this way we have been able to obtain the front view projections as well as the top view projections of the uncut hexagonal pyramid, which happens to be resting onto its hexagonal base onto the horizontal plane, while two of its edges, they were inclined at an angle of 30 degree with respect to the vertical plane. Now we have been provided with the information that there are two adjacent section planes or the auxiliary inclined planes which are going to pass through the midpoint of the axis. So let us mark the midpoint of the axis. So we know that the height of the axis happens to be 70 millimeter. So we can measure this distance of the midpoint 35 millimeter from the base or 35 millimeter from the apex point. So here we are going to mark this distance as 35 millimeter from the apex point. Once we mark this midpoint of the axis into the front view projections, now the two cutting planes which are going to cut this particular hexagonal pyramid, they will be inclined at an angle of 45 degree to the horizontal plane, that is the left side cutting plane. It is inclined at an angle of 45 degree to the horizontal plane. So this is our cutting plane number 1. So here we have got one auxiliary inclined plane that is perpendicular to VP and inclined to HP at an angle of 45 degree, passing through the midpoint and cutting this hexagonal pyramid into this orientation. Similarly, we have got the second cutting plane which is also an auxiliary inclined plane that is perpendicular to VP and inclined to HP at an angle of 30 degree, passing through the midpoint of this particular hexagonal pyramid. Now this is the cutting plane 2. So cutting plane 1 has been marked with blue color. The cutting plane 2nd has been marked with red color over here. So this portion of the hexagonal pyramid has been cut by these two auxiliary inclined cutting planes, and this will be removed. Now we are left with this portion of the solid over here. So this portion of the solid, it is left behind after the truncation of this hexagonal pyramid by two cutting planes which are inclined at the angles of 45 degree and 30 degree with respect to the horizontal plane over here. Now we are required to obtain the sectional top view corresponding to these two cutting planes, and we are also required to evaluate the true shapes of the cut sections which are obtained by cutting plane 1 and the cutting plane 2 over there. So let us first of all proceed with evaluation of the sectional top view of the solid which has been cut by these two cutting planes. Now we know that corresponding to cutting plane 1, that is AIP 1, which is inclined at an angle of 45 degree. So this cutting plane, it intersects the slant edges O-A' and O-B' at the points 1' and 2' respectively. So O-A' has been cut at the point 1', while the slant edge O-B' has been cut by this cutting plane at the point 2' over here. So the 2 points 1' and 2' they have been obtained into the front view projections over here. Now the second 2 points which are available with us corresponding to this cutting plane, they are 3' and 6' over here. So 3' it is the point of intersection of the cutting plane 1 with the slant edge O-C' over here, while the slant edge O-F' has been cut by this cutting plane 1 at the point 6' over here. So this way another 2 points we have been able to obtain corresponding to cutting plane 1 intersecting with the hexagonal pyramid. Now we know that corresponding to the cutting plane number 2nd, so points 3' and 6' they will remain the same. So 3' and 6' points, they will be the points of intersection of the cutting plane number 2 also with respect to the slant edges O-C' and O-F' respectively. Why? Because the cutting plane 2 also passes through the midpoint. So 3' and 6' will be the common points of intersection corresponding to the cutting planes 1 and 2 respectively over here. So while corresponding to the cutting plane number 2, this cutting plane, it intersects the solid at an angle of 30 degree. So this way we are able to obtain 2 points of intersection 4' and 5' corresponding to the intersection of the cutting plane with the slant edges O-D' and O-E' over here. So 4' is the point which is the point of intersection of the cutting plane number 2 with the slant edge O-D', while 5' point, it is the point of intersection of the cutting plane number 2 with the slant edge O-E' over here. So all these 6 points, they have been appropriately located into the front view projections. Now the blue projection, they are corresponding to the cutting plane number 1, while the red projection, they are corresponding to the cutting plane number 2. So 3' and 6', so they will be the common points of intersection over there with respect to cutting plane 1 as well as the cutting plane 2. Now let us obtain these 6 points of intersection into the top view projections over here. So now from points 1' and 2', if we draw a vertical projector line, now the intersection of this vertical projector line into the top view projection with the slant edge OA, it will provide us with the location of the point 1 in the top view projection, while the intersection of this vertical projector drawn through the point 2' over here into the plan projection view with the slant generator OB over here. So this will provide us with the location of the point 2 in the top view projection. So we are able to obtain points 1 and 2 corresponding to the cutting plane number 1 into the top view projections over here. Now let us draw a vertical projector through the points 3' and 6' into the plan projection view and evaluate where do these 2 points they are lying into the top view projections over here. So if we draw a vertical projector line through 3' and 6', now if we just extend this vertical projector into the plan projection view, we are not able to obtain any point of intersection over here. Reason? Because these, they are lying into the perpendicular direction, that is OF and OC, it lies into the perpendicular direction so far as the front view projections they are concerned. So they have coincided with each other. So we are not able to see or evaluate any point of intersection corresponding to this vertical projector drawn through the points 3' and 6' into the plan projection view. So how do we obtain the points 3 and 6 to the top view projections over here? Now we have to look at the solid from the side view. So we know the relationship between this radius and the height. So more the height, lesser will be the radius, lesser the height, more will be the radius. So using this phenomena, now we know that corresponding to the points 3' and 6'. So this is the height at which the cutting plane passes through the axis of this particular hexagonal pyramid. Now corresponding to this height, let us obtain this radius over here. So from points 3' and 6', as we are going to look at the solid from the side view over here. So these 2 points, they will be projected or transferred onto the projectors O'(A' and O'(B' at 2 points, that is 3'1' and 6'1' over here. So 3'1' point is corresponding to the point 3', 6'1' point has been obtained corresponding to the point 6' over here. So this radius we have been able to obtain. Now corresponding to this radius or the points 3'1' and 6'1' which are obtained onto the slant generators O'(A' and O'(B'. Now let us project these points into the top view projections over here. So if we draw the vertical projectors through 3'1' and 6'1', now the point which is obtained onto this slant generator OA, this point name will be point 6'1". The point of intersection of the vertical projector drawn through these 2 points with the slant generator OB will provide us with the location of the point 3'1" in the top view projection. Now what we have to do, with O point as the compass point, now we will open the compass is equal to O61 and mark this radius or transfer this radius onto the slant edge OF over here. Similarly, with O as the center point, we'll open the compass is equal to O31 and draw an arc in this direction so that we are able to obtain a point of intersection of this arc with the slant generator OC. So this radius has been transferred into the top view projections over here. So this point will be obtained as 0.3. This point will be obtained as 0.6. So this way, the points of intersections of the cutting plane with the slant generators OC, that is 0.3, and the intersection point of the cutting plane with the slant generator OF, that is 0.6. So these 2 points, they have been obtained into the top view projections over here. So next we have got the points 4 dash and 5 dash over here. So through points 4 dash and 5 dash, if we draw a vertical projector line, so wherever this vertical projector emerging from the point 4 dash, which happens to lie onto the slant generator O dash D dash, it intersects with the top view projections corresponding to the slant generator OD, we obtain the point number 4 over here. Similarly, wherever the vertical projector drawn through the point 5 dash, which happens to lie onto the slant generator O dash E dash over here, it intersects with the top view projections corresponding to the slant generator OE, we obtain the point number 5 over here. So this way, all the 6 points 1, 2, 3, 4, 5 and 6 corresponding to the 2 cutting planes, they have been obtained. So the blue one, it corresponds to the cutting plane number 1, and the red one projections, so these projections have been obtained corresponding to the cutting plane number 2. Now we can observe, since cutting plane number 1 and cutting plane number 2, both of them, they are not parallel to the XY reference line or the horizontal plane. So both of these auxiliary inclined planes, they happen to be inclined with respect to HP at angles of inclinations 45 degree and 30 degree respectively. So the plan projections which are obtained corresponding to cutting plane 1. So this is plan projections for cutting plane number 1 drawn with the help of blue color over here. So 1, 2, 3, 6. So these projections, they represent the sectioned top view projections or the apparent shape projections corresponding to the cutting plane 1. Similarly, the plan projections which are marked with red, that is 3, 4, 5 and 6, that is marked with red color, which have been observed onto the top view projections over here. They also represent sectional top view projections corresponding to the cutting plane number 2, and both of them, they happen to be the apparent shape projections over here. So whatever is the remaining portion of the slant edges over here, so those we have joined accordingly. So this way we are able to obtain sectional top view projection corresponding to the cutting plane 1 marked with blue color, and the sectional top view projections corresponding to the cutting plane 2, which has been marked with red color over here. And both of these projections, they are the apparent shape projections of the 2 cut sections which have been cut by cutting plane 1 and cutting plane number 2 respectively over here. So now we are required to obtain the true shape of the 2 cut sections over here. This is cut section number 1. This is cut section number 2. So corresponding to these 2 cut sections, the true shapes, they have to be obtained independently and also side by side. Now this is our cutting plane 1. So once we are going to look at the solid from this direction, now we have to draw an auxiliary inclined plane which will be x1, y1. So this auxiliary inclined plane x1, y1 has been drawn parallel to the cutting plane number 1. Now once we draw this auxiliary inclined plane x1, y1 parallel to this cut section, that is parallel to 1 dash, 2 dash, 3 dash and 6 dash cut section over here. Now the projectors drawn through the points 1 dash 2 dash and drawn through the points 3 dash and 6 dash. So these two projectors, they will provide us with the true shape projections corresponding to the cut section number 1 over here, corresponding to the cutting plane number 1. So how the true shape projections they will be obtained? So we already know that onto the auxiliary inclined plane which is drawn parallel to this cut section number 1. Now we are going to obtain the true shape of the projections using the auxiliary plan view over here. So the distances of the plan projection, they have to be taken from these positions over here. We have to measure distance of point 1 from the XY reference line. Distance of point 2 we have to measure from the XY reference line, and onto this projector line which has emerged from points 1 dash and 2 dash. Now 2 points you can check we are going to mark. So the distance of point 1, it will be this distance in the plan projection view from the XY reference line. So once we measure this distance of point 1 from the XY reference line, so onto the projector line drawn through the point 1 dash, same distance will be plotted over here. So we have obtained the point 1 1 of the plan projection view over here. This is the auxiliary plan projection view. Similarly, we measure the distance of the point 2 from the XY reference line over here. So whatever is the distance of point 2 from the XY reference line, now onto the projector line drawn through the point 2 dash ahead of the plane, the same distance we are going to mark it over here. So this distance of point 21 will be equal to the distance of point 2 from the XY reference line. So this distance will be marked ahead of the plane over here. Similarly, we measure the distance of the point 3 over here from the XY reference line. So this is the distance of the point 3 from the XY reference line. Now onto the projector line corresponding to the point 3 dash over here. So onto this projector line ahead of the plane, same distance we are going to mark, and we will be obtaining the point 31 onto the auxiliary plan projection view over here. And finally, corresponding to the point number 6, again we are going to measure this distance of point 6 from the XY reference line. And now onto the projection line corresponding to the point 6 dash ahead of the plane, same distance we are going to mark corresponding to point 6. So this way we are able to evaluate point 61 corresponding to the auxiliary plan view. So once we obtain these 4 points, and we are going to join this using blue color line over here. So this is the section surface true shape that we have been able to obtain. So this is the true shape of the cut section 1 dash, 2 dash, 3 dash, C dash, which has been obtained by virtue of cutting of this hexagonal pyramid by cutting plane number 1. So this has been marked by blue color. Now we also know that there is second cutting plane inclined at an angle of 30 degree. So this auxiliary inclined plane at an angle of 30 degree has cut the solid passing through the midpoint, thereby yielding us with these 4 points over here, 3 dash, 4 dash, 5 dash and 6 dash over here. So this cut section true shape now we are required to evaluate. So once we mark these arrows over here, now we are going to look at this cut section into this direction. So now how the true shape of this cut section will be obtained? So once again, another auxiliary inclined plane x2, y2. We are going to draw parallel to this cut section or parallel to the cutting plane number 2, which is oriented at an angle of 30 degree with respect to the horizontal plane. Now since this cut section happens to be parallel to this auxiliary inclined plane x2, y2, so the projections of this cut section which are obtained onto this auxiliary inclined plane x2, y2 will provide us with the true shape projections of this cut section into the auxiliary plan projections over here. So once again, corresponding to the points 3 dash and 6 dash and points 4 dash and 5 dash. So the distances we are going to measure from the XY reference line, and same distances we are going to plot onto the projection points which are going to emerge from the front view projection points over here. So let us proceed. So here we have drawn two perpendicular projector lines emerging from the points 4 dash 5 dash and 3 dash 6 dash onto this auxiliary inclined plane x2 y2. Now we know that this is point number 4 dash. So let us measure the distance of the point number 4 from the XY reference line in the plan projection view. So once we measure this distance in the original plan projection view, now from the projector which is emerging from 4 dash ahead of the plane, the same distance of point 4 from the XY reference line will be marked over here. So this distance ahead of this AIP will be marked over here. So we are going to obtain the point 41 in the auxiliary plan projection view over here. Similarly, we know this is the location of the point 5 in the plan projection view. So we are going to measure this distance of the point 5 from the XY reference line. Now from the elevation projection point 5 dash, this is the projection line. So onto this projector line ahead of the plane. So this distance of 0.51 from the auxiliary inclined plane x2 y2 will be equal to the distance of the 0.5 from the XY reference line. So this distance has been appropriately transferred or marked over here. Now we have got the points 3 dash and 6 dash. Now corresponding to the point number 6, we have measured the distance of the point 6 in the plan projection view over here, and from the front view projections corresponding to the point 6 dash onto this projector line, the same distance we have marked it out over here ahead of the plane. So this distance of 0.61 from the AIP x2 y2, it is same as distance of the 0.6 from the XY reference line. Similarly, the distance of 0.3 from the XY reference line has been measured, and from the front view projections 3 dash point, we have drawn a projector line, and now ahead of the plane same distance we have marked it out over here. So we have been able to obtain the point 31 in the auxiliary plan projection view over here. So having obtained the points 31, 41, 51, 61 corresponding to the intersection of the cutting plane number 2 with the hexagonal pyramid, so now we have been able to obtain the true shape projections in the auxiliary plan projections which have been obtained on the auxiliary inclined plane x2 y2, which happen to be parallel to the section plane number 2 or the cutting plane number 2. So these are true shape projections for this section surface which is inclined at an angle of 30 degree with respect to the horizontal plane. So the section top view for cutting plane number 1 and 2, they have been obtained. The true shapes corresponding to cutting plane number 1 and 2, they have been obtained. Now we are also required to obtain the true shapes of both of these cut sections onto the single plane. So usually we are not able to obtain these two true shapes onto a single plane. So if we have to draw, if we have been forced to obtain these two true shapes onto the same plane, what we have to do? So please check. We have already obtained the true shape of this cut section over here. So this portion of the cutting plane, if we rotate it over here, if we rotate these projections corresponding to this cut section over here, so what we can do with 3 dash 6 dash as the center point, will open the compass is equal to 3 dash 6 dash and 4 dash 5 dash over here. So once we draw this arc over here, once we mark this arc over here, so forcibly we have transferred this cut section from this orientation into new orientation which will be lying alongside the previous orientation of the cut section of the cutting plane number 1. That is, we have transferred this cut section from this position into the new position, and now the two new points which have been obtained, they will be 4-1 dash and 5-1 dash. So this is done artificially. This projections we have made, but ultimately this cutting plane will be located only in this orientation. So now once we have transferred this cut section from this orientation into this orientation, now the projectors from 4-1 dash and 5-1 dash, that is orange color projections, we are going to draw it over here using the auxiliary plan method. So the same distances now we are going to mark, because 3-1 and 6-1 they were already available. So only 2 points now we need to obtain over here, that is 4-1 and 5-1. So let us measure the distance of the point 4 from the XY reference line. Let us measure the distance of the point 5 from the XY reference line, and these two distances we are going to plot over here. So distance of point 4 from XY reference line we have measured and plotted it over here ahead of the plane, yielding us with the point 4-1 in the plan projection view, which is a rotated view. It is not the original view. This is going to be a rotated view over here. Similarly, the distance of point 5 from the XY reference line now we have measured, and we are going to mark the same distance ahead of the plane corresponding to this projector 5-1 dash over here. So this way, onto this rotated view, 6-1, 3-1, 4-1 and 5-1, they have been obtained. Now this rotated true shape we have been able to mark over here using red color projection. So side by side also on the same plane we have been able to obtain the true shape of the cutting plane number 2, which is a rotated view. Mind you, usually this is the actual cutting plane. So true shape has already been obtained over here. If we are required to draw both of these true shapes onto the single plane, now we have rotated this cut section into the new orientation. So this is only for the purpose of representation that we have drawn it out over here. Otherwise, actually this is the true shape of the cut section for the cutting plane number 1. This is true shape of the cut section for the cutting plane number 2. So this is only for the representation. We have drawn a rotated view over here. So this way we have been able to obtain the sectional top view projections, the true shape projections of the cut sections, and the true shape projections onto the single plane corresponding to this truncated hexagonal pyramid, which has been cut by two auxiliary inclined planes which are inclined at an angle of 45 degree and 30 degree with respect to the horizontal plane, and both of these cutting planes, they happen to be passing through the midpoint of the axis over there. So this is all for today. So I hope that through this discussion you would have understood about the procedure, how do we evaluate true shapes as well as the section top view projections when there is truncated hexagonal pyramid which has been cut by two different cutting planes over there. We will be continuing with further discussion regarding few more illustrative cases of sections of the solids in the coming lectures. So thank you very much. Thanks a lot.